Hi, my name is Maciej, and I know that I'm the only thing separating you and lunch, so I'll try to keeping it brief. I will be talking about a pet project that me and my friend Rafał have been doing for the last couple of months. Is Rafał in the audience somewhere? Like, where is? Yeah, he's there. He's the guy in the back. Actually, this pet project of ours is just an excuse to talk about a larger thing happening in the industry, as I see it. There won't be a lot of Scala code at this presentation. I will talk more about how we deploy applications these days and where I think it's going. How many of you deliver applications to the cloud or web applications or these kinds of stuff? Okay, I can see most of the audience, as I expected. Okay, great. So that's me. I'm a software engineer at Adform. We happen to be the main sponsor of this event, so if you want to know more about us, just go check out the booth. Talk to the guys there. They're absolutely awesome. I've been a Scala developer for over 3 years, around 4, I don't know, somewhere around this time. And I spent around 10 years around the JVM, basically. That's me. Okay, so the agenda. I'll give you a very brief subjective view of the history of how I deploy applications and how I think the industry as a whole did it, where I come from. Then we'll talk a little bit about how Akka Cluster is constructed, and we'll finish off with a deployment demo. So it's a subjective point of view. You might not agree with all the things I say, but I've been there. So it all started, for me, I came to the industry writing PHP scripts and deploying them via FTP, uploading them via FTP to a production server. And we edited them, there. So this is how my applications were deployed and managed back in the days. It's kind of embarrassing to say this, but I have to admit it. This is how I was doing it. A couple of years later, things have changed for me, and I think also for the industry as well. We started having, deploy stuff to servers and VMs. VMs became a thing around a decade ago, I guess. We had the Chefs and Ansibles, which manage our infrastructure and gave us, a very declarative way of saying, okay, I want this system library to be on this host in this version. I want this resource to be present. I want this resource not to be present. I want this thing to be running or not. And you'd set up your system libraries, packages, your JVM version to be the correct one on your machine. You do the same, for your whatever logging, monitoring infrastructure on this host. The whole thing was still very much what I would call a host-centric infrastructure. So you'd still concentrate on the host, right? Your machine, your actual, be it a bare metal server or a VM, would be in the center of your attention. Moreover, it would be sort of mutable in the sense that you change it. And I think this is the old way of doing things. This is what I discovered while working on Akka Cluster etc.d and while playing around with the technologies that are popping out in this area. And one of the reasons is this guy came along, actually, this guy. Container level virtualization and Docker, which largely popularized it, I think will change the way we think of application deployment and where it's heading. So if you could forget about Docker running on a host, or if you could forget about Docker running on any of your machines, just forget about machines for a moment, right? Just think about the containers. Wouldn't it be cool if you could just, throw them across the wall and have your cluster, your infrastructure as a whole, figure out how to run them. So you just specify, okay, I want to give this amount of resources to my containers, and have your infrastructure figure out, okay, I have this amount of servers, I have this amount of machines, so where can I run where I can run this stuff, and have it also figure out, yeah, so this node went down, and we need this container to be running, I don't know, with 5 replicas, so let's migrate it somewhere else. So just like that. It took me an hour to prepare this slide, but yeah. So I think this is the new way, and I think this will sort of become a standard how we think of applications, and it has some impact on how we do things. And Akka Cluster etc.d in particular tries to find is a solution for when working with Akka Cluster. So I'm kind of wondering, do you recognize these logos? The one on the top, who recognizes? Okay, like quite a lot of people, like I don't know, 30%. This one on the left. Still a few. Okay. So these are free. They're quite different tools, but conceptually they allow you to schedule jobs on your cluster. Mesos, Kubernetes, and Docker Swarm. There are a couple of few more. They are different. However, we don't have a lot of time to go into explaining exactly how they differ and what are the strong and weak points here. For the purpose of this presentation, I will demo Kubernetes because this happens to be the one I was playing the most with when working on the project. Okay, so why would you like to use it? Why would you actually want to use a tool like this? So why would you want to have, like, you had this slide with this thing, and you imagine there is a guy like in the server room who just catches your containers, right? And this is Kubernetes basically. So you have this catcher guy who just catches your container and figures out where to put it and how to run it. So one of the reasons is you have better resource utilization. If with VMs you statically declared how many resources your VM will have, and if you had a VM per service, that meant that some of the resources were underutilized when you weren't in peak load for which you prepared. That's one thing. The other thing is self-healing. Tools like that allow you to do self-healing very, very easily because, well, they provide self-healing for you. So you don't have to care, okay, like my container went down, so you don't have to program for that, right? You don't have to write the whatever scripts that will handle such scenario. The container, like the cluster manager will manage that for you. And horizontal scaling, it becomes trivial, absolutely trivial. And this is something I'll demo a little bit later. Okay, so two problems that, like, the biggest problem that comes out of using such tools, on the other hand, is that you don't know where your containers live. And you don't want to know. Like, you don't really care what's the IP address of the machine it's running on. Why would you, like, that's not a thing you should care about, right? In this world. And traditionally, this thing was solved by service discovery, and as much as service discovery is not really a new thing, it is unavoidable in this scenario. And this is what we strive to provide. And so what about Akka Cluster? So are you all familiar with Akka? Like everyone? Akka Cluster? People running in production, Akka Cluster? Oh yeah, there is one hand up there. There are two in the back. So like really, very, very, very few people. Cool. So for those of you who are not familiar, so basically it's actors of the network. That's the simplest way to explain it. And the Akka Cluster documentation says Akka Cluster provides a fault-tolerant, decentralized, peer-to-peer based cluster membership service with no single point of failure or no single point of bottleneck. It's a mouthful. But let's look at the second word here, which is decentralized. So it means, okay, we have no sort of central point, no actor, no node in this cluster acts as sort of this, master to which you connect to, which is kind of cool. However, in order to bootstrap such a cluster, Akka Cluster uses this concept of seed nodes. So you have a couple of nodes that are present in the network, and you can connect to them, and this becomes a problem, right? Because you specify them like this, right? So they're available on these hosts and on these ports, and you cannot guarantee it if you don't know where your containers are, right? You don't know where they are running. So traditionally, we do service discovery, so we invert this. We say, okay, like this is, yeah, so Akka Cluster etcd. So like, yeah, I'm like this node of the Akka cluster, like this node which is, Akka cluster based, and I went up, so I'm announcing myself to etcd and saying, oh, yeah, I'm here. You can, like, I'm here. And Akka Cluster etcd will help you to figure out, will provide you the seed list, and will allow you to connect to these random nodes. It's implemented as an Akka extension. Very simple stuff. You can clone it, play with it. It's available on GitHub. If you Google it, you'll probably find it. And this is how we started. That's basically only 2 lines of Scala code you will see in this presentation. For those of you not familiar with etcd, it's basically one of the CoreOS tools they use. They advertise it as etc distributed. So it's, you can think of it like as a place you store your crucial configuration data, and yeah, like it has all these properties which we found useful. Now the way you configure it is you provide, well, you still need. So you don't need an initial contact points of the cluster being like the hosts in the hosts where the nodes of the cluster are, but you need sort of a stable contact point for where etcd is. And in the Kubernetes environment, we use something which is called a service there, and the service registers you can register like here a domain name which will be visible and for all the nodes of the cluster, of the Kubernetes cluster, not the Akka etcd cluster, as etcd. This is how the service is called, and it will be available on this domain, and we specify the port. That's basically it. Cool. So I really wanted to do the whole deployment demo, like from start to finish, live. However, setting up the cluster takes just a little bit too long. So I'll just walk you through the initial steps and show you how you can rescale this thing and scale it down, scale it up. And I'll show you the self-healing properties of Kubernetes. Okay. So that's the application we're running. Oh, just one thing. So the repository I've mentioned, it contains 3 projects. One is an etcd client that we are currently in the process of extracting as a separate thing altogether. The other thing is the discovery mechanism. So this is the one you import to get this. You depend on it in order to get this nice cluster discovery thingy. And there is an example application which has this very nice front end. And 2 things it does. It allows you to run. So actually, actually it's one thing it does. It lists the Akka cluster nodes which are connected to the cluster. It lists the roles in which they are in. And this nice star there is the leader in every of the roles. So you get a leader election based on etcd for free. Before I show you the demo, I just need to explain 2 concepts which are used in Kubernetes. One is a replication controller, and the other one is a service. A replication controller is a declarative way of saying, okay, yay, I have this container running. So I have this container, and please, Kubernetes, make sure that this container is running in 3 or 4 or 5 replicas, or whatever number of replicas. And just take care of this. I don't really care where it is. I just want you to take care of this. And the service is sort of this thing declaratively saying, okay, listen, so I have these containers deployed. Actually, they are pods, but let's speak of containers for the ones who are not familiar. It's a little bit to simplify stuff. So I have these pods deployed, containers. And since we don't know where they are, but like they provide some sort of service, right, to either to your application inside in your infrastructure or to the outside. And yeah, it would be really cool if we could just declaratively say, okay, this service is available here, and put a load balancer in front of it. So that's basically it. I'm using Google Container Engine to start up a cluster. It's pretty easy. You just type in these 3 lines. Yeah. And we deploy etc.d. Actually, if you look at the deployment descriptors, just don't use it, don't do it in production. It's just one instance of etc.d. You should normally have at least 5 of them, and for them to form a quorum. We have the Cloud Monitor frontend, and we have the Cloud Monitor backend. Frontend and backend, well, the backend does absolutely nothing. It just registers itself. The frontend displays this nice frontend, and that's all. Create it. So these are the replication controllers and the services. The service for etc.d, this is an internal service, so the etc.d port is etc.d is available at etc.d hostname and port 2739. And this is an example of how is already okay. So you probably cannot see the lines which are grayed out, and the ones which are just straight white. Cool. So you see the name of the application, the image which I'm pulling, the name of the image, and the cluster role. Like cluster role is saying to the Akka cluster, okay, like I want this node to be in this role, and I want you to execute this behavior based on that role. That's all there is to it. Yes, and you have a label. So it's labeled app cluster monitor frontend, and this label will become important here in the service. Say, okay, like, hey, let me take this app cluster monitor frontend, which exposes this port, and please make it available under cluster monitor frontend. And if you could also plug it into the external load balancers. That's all there is to it. Okay, so demo. Oh, give me a while. I need to set up screen mirroring here. Let's see if it works. Oh God, no, that's terrible. Well, shouldn't be very difficult to fix. I hope you can see it now. So we have this. We have the cluster. We have one backend, one frontend. They do absolutely, like, the frontend does something, but the backend doesn't do anything. And in the window, in the console here, can you actually see it? Oh, great. The ones in the back? Great. Okay, I'll just make it so that. It's playing around with this stuff. It's very cool. Okay, let's clear it, and let's see. So I want, actually, wouldn't it be cool if we're experiencing peak load? Say this is our sort of production application. We're under high load right now. So wouldn't it be cool if we could have 3 backends running instead of 1? Sure. Let's start 3 replicas. Let me just check how the pod creation is going here. Oh, one is already up. Oh, cool. So we have, as you can see, 2 of the pods are already running. One is being created. Probably the one which is created still. It's probably still pulling the image. I was playing with this thing before, so it probably had the image on the other one faster. So as you can see, scaling the thing becomes trivial. You just type in. Let's just kill one now. You just type in one simple command against Kubernetes, and it will scale the thing for you. It will just, well, actually, it will ensure that the current number of replicas of a given container matches the desired one. So you say, okay, hey, Kubernetes, I want the desired number of replicas to be 2 for this service, for this replication controller, so make it so. And let's say, so this goes for horizontal scaling. Let's say, there is a problem with our node and or with our container or whatnot, whatever, and it goes down. For the purpose of this demo, I'll just delete this pod, and which you'll see will happen in a second. That this thing will. Let's hope it will go down. Okay, it's going down, and another one should replace it in a second. Yeah, great. We can obviously do the same thing for I guess all of you are clicking now in this. Some of you might copy the IP address if you can see it, and are clicking compulsively on the front end. So we need to scale it because we were experiencing really a big peak load of users of the cluster monitor. So let's scale it, and let's get 3 instances of it. Great, it's running. No matter how many times I refresh it, it will get. It will work, basically. Okay, cool. That's all I have prepared. I'm finished quite soon. For that, that's a demo backup. I didn't have to use it. So to recap, just to recap. Hey. Okay. So it's very brief to show you what I've learned about application deployment and where I think application deployment and management is going for the cloud. I showed you how we work with Akka Cluster and Akka Cluster etc.d. You can check out the source code, and you can check out how we implemented this. And if you have questions, just feel free to grab me or Rafał. We will gladly answer all your questions. Technical stuff, and we looked at Kubernetes. Actually, we have time. Do we do questions, or so are there any? Yeah, here in the front.
On Kubernetes, you use orchestration. It means that it controls your containers. Yes, but here, for example, you cannot run your containers with Akka if you don't have etc.d. So my question is, how many containers you can run without having a lot of problems with order and these dependencies? And for example, if etc.d goes down, what happens with your cluster? Yes.
So if etc.d goes down, what happens with the cluster?
And how you orchestrate a lot of containers?
We haven't tested it, to be honest, yet. It's a pet project. So I'll be very honest with you.
And now
we don't run it in production.
If you have a lot of containers, how this Kubernetes will handle the orchestrations to make this really work?
How will it handle? Sorry.
How it handle the orchestration of a lot of containers. So if one server uses another and one of them are dying, then how the other will know about that?
I would take this question offline. I'll just, because it's a bit more about Kubernetes itself, which might not be interesting for everyone. So I'll just grab me afterwards, and we'll talk about it. Okay, cool. So I guess the people are going out for lunch. Thanks for listening.